Okay, so it's a continuation of the previous day's class, and we are dealing evaluation of definite integrals by substitution. And we have solved 4 problems already, and there are 6 more. So we plan to solve all the problems, and let's solve the next problem. So the next one is integral 0 to 1 sine inverse of 2x over 1 plus x squared times dx. And here too we can solve the problem in 2 different ways. And let's solve the problem in 2 different ways. And substitution is a different thing. I'll tell you later. Equals. Now, I'll put x equals tan theta, or x equals tan theta. So we know when you get an inverse trigonometric function, sometimes to simplify, sometimes to integrate, sometimes to differentiate, there is no direct process applied in inverse trigonometric function. Before you integrate, before you differentiate, you have to express the given inverse trigonometric function in its simplest form, right? So simplification, we are doing simplification here, and I told you a shortcut to write the simplest form. If it's sine inverse, you have to do something. Sometimes you have to simplify, or sometimes you have to substitute and make sine here and apply the property called sine inverse sine x equals x. So put x equal tan theta, and theta equal then tan inverse of x, right? Now we substitute, and now I'm not changing the limit, keeping the limit same. Integral 0 to 1 sine inverse of 2 tan theta, but x will become tan theta over 1 plus tan squared theta dx, right? Dx equals integral 0 to 1 sine inverse of, we know this is a trigonometric identity. 2 tan theta over 1 plus tan squared theta is sine 2 theta. So sine inverse sine 2 theta dx equals integral 0 to 1 sine inverse of sine 2 theta dx equals integral 0 to 1 sine inverse sine x is a property of the first property of inverse trigonometric function. So sine inverse sine 2 theta is nothing but 2 theta and dx. And now we change this theta to tan inverse x. Into 0 to 1, 2 times tan inverse x times dx. And this is the first process of integrating this term, right? While I write it like integral 0 to 1, I just rewrite the term as 2 times tan inverse x times dx as 0 to 1 tan inverse x times 2 times dx, right? Because I just plan to apply integration by parts here, the product rule of integration. And the first function is tan inverse x. In ILATE principle, you have to apply ILATE principle, I-L-A-T-E, where a is the algebraic function and 2 is an algebraic function. Tan inverse x, T, stands for inverse trigonometric function, and tan inverse x is an inverse trigonometric function. So T, I-L-A-T-E. So tan inverse x is an inverse trigonometric function. So it comes first, I-L-A-T-E, I, inverse trigonometric function, and L-A. After that, there comes A, algebraic function. So tan inverse x must be the first function. So I write the integral straight, tan inverse x times integral of the second function. So first function times integral of second function is 2x minus integral of derivative of the first one, 1 over 1 plus x squared times integral of the second one, 2x times dx equals 2x times tan inverse x minus. See, here we have a rational function where we have a numerator and a denominator, and here the derivative of denominator is there in numerator, so we can apply a shortcut, and the L is log mod 1 plus x squared to the limit 0 to 1. Now we have to apply the limit. First we apply 1 here, and no need of applying 0 here because this term will become 0 and this term 2 will become 0. So we apply 1. So 2 times 1 times tan inverse of 1 minus log of 1 plus 1. Right. Minus 0. When you apply the 0, it will become 0. So it's 2 times pi over 4. because tan inverse 1 is pi over 4 minus log 2 is, and I can write like 2 times cancel, is pi over 2 minus log 2 is the value. So in this way you can evaluate this definite integral, and the value is pi by 2 minus log 2. So keep in mind the value is pi by 2 minus log 2. This is one technique to solve this problem. And actually in this topic they ask us, or they expect you solve the problem in a different way. So let's solve in that method. If you apply this method, no problem, you'll get marks, but that's a better way. And that method is actually called integration by substitution. So let's try that method too. Here is integral 0 to 1 sine inverse of twice x over 1 plus x squared times dx is the problem. And now I substitute the previous, the same way. I substitute, put x equals tan theta. Now I differentiate, I get dx over d theta, because we are differentiating the term of x with respect to theta. So dx over d theta equals sec squared theta, and dx equals sec squared theta d theta. Now let's do one. Let's change the limit. Now for the time being, see 0 to 1 limit of x. Now we know. I'll substitute here. Theta equals tan inverse x, and this one, right? And if x equals 0, theta equals tan inverse 0, which is 0. If x equals 0, that becomes tan inverse 0, and theta equals 0, where tan inverse 0 is 0. And if x equals 1, x approaches 1 here, then theta will become tan inverse of 1, which is pi over 4. You know that. And this is the real substitution. Now let's substitute. Now integral 0 to 1 become 0 to pi by 4. That's 0 to pi over 4 sine inverse of 2 tan theta over 1 plus tan squared theta times, what dx now, as a change, is sec squared theta d theta equals integral 0 to pi over 4 sine inverse sine 2 theta, because this is a trigonometric identity. 2 tan theta over 1 plus tan squared theta is sine 2 theta times sec squared theta d theta equals integral 0 to pi by 4 sine inverse sine 2 theta is 2 theta sec squared theta d theta, and that's it. Now we change the variable from x to theta. Now see, the limits are 2 and theta. Now we apply by parts here. So equals, here there are two functions. The function is product of two other different functions. 2 theta is the first one, and sec squared theta is the second one, right? Where 2 theta is an algebraic function and sec squared theta is a trigonometric function. So we apply by parts, and the first one must be 2 theta. So first function, that's 2 theta times integral of sec squared theta. So you write a thing, whose derivative is this sec squared theta? Is the derivative of tan theta. So integral of sec squared theta must be tan theta minus integral of, I'm applying integration by parts, right? First function times second function. So how it goes? First function times integral of second function minus integral of derivative of the first function times integral of second function. And the derivative of 2 theta is 2, right? Times integral of sec squared theta is tan theta times d theta. And in this step, I'm not writing any limit. Equals 2 theta tan theta minus, let that 2 be there. 2 is a constant, we take it up, and tan theta is a function, and we know that the integral of tan theta is log mod sec theta, and integration is over to the limit 0 to pi over 4 equals, now here too, there is no point in applying 0, because every term will become 0 when you apply the value 0. Now apply pi by 4 here, so 2 times, first for theta, pi over 4 times tan pi over 4 minus 2 log sec pi over 4 minus, if you apply 0 for theta, it will become 0. For every time it will become 0. And cancel 2 times equals pi by 2. Tan inverse pi by 4 is tan 45. The value is 1. So pi by 2 times pi is this 1 is 2 log. You know what's cos pi by 4? Cos pi by 4 is 1 over root 2. So sec pi by 4 is its reciprocal. That's root 2. Right. You get the same value in the previous method too. So this is how we solve the problem. And there are 2 methods. And see, I solved this problem in 2 different ways. And you have to choose a method which you are comfortable with. Right. If you feel this is easier for you, go for this. And if you feel the previous method is better, go for that. So there are 2 methods to solve the same problem. Correct? So hope you understand. Now we move to the next problem. Right, we plan to solve every problem in this topic. The next one is integral. It's an easy one. Integral 0 to 2 x times square root of x plus 2 times dx. Here too we substitute. Right. Put u equals x plus 2. We take this term as u equals x plus 2. You know what's x then? It's u minus 2. If u equals x plus 2, we take this term as u, and then x equals u minus 2. And now we change the limits to, and x equals 0. This is a function of x, so the limits are in x, so x equals 0, then u equals 2. 0 plus 2 becomes 2. And x is approaching to, moving to 2, so x equals 2, then u will become 4. 2 plus 2, 4. So x equals 0, u equals 2, x equals 2, u equals 4. So if x is from 0 to 2, is from 2 to 4. Now let's substitute integral 2 to 4. So 0 to 2 will become 2 to 4 when we change the variable to u. And x is u minus 2 times square root of u times, let's differentiate, that's a process. Du over dx is equals 1 and du equals dx. Right? It's too easy. So dx and du are equal, like du here, and integral 2 to 4 u minus 2 times u raised to half times du. And to integrate, I multiply both these terms using u raised to half. So 2 to 4 u raised to u times u, actually u raised to 1, u raised to half, minus 2 times u raised to half, times du equals integral 2 to 4. How you multiply u and u? We have add powers. So u raised to 1 plus half is 3 over 2. 1 plus half is 1 and a half, which is 3 over 2, minus 2 raised to 1 over 2 times du. Now it's time to integrate. So how we integrate? So u raised to. So we have to add 1 with its power and subtract, divide the same. So 3 over 2 plus 1 over 3 over 3 over 2 plus 1 plus or minus 2 raised to 1 over 2 plus 1 over 1 over 2 plus 1. And to the limit to 4. Now the simplification is there, and u raised to 5 over 2 over 5 over 2 minus 2 times u raised to 3 over 2 over 3 over 2 2 to 4. The simplification, 3 over 2 plus 1 is 5 over 2. Now equals, I use the reciprocal of this one, 2 over 5 u raised to 5 over 2 minus 4 over 3. Hope you understand. 2 is there, and I use the reciprocal of this term. The reciprocal of 3 over 2 is 2 over 3. So 2 times 2 is 4, and u raised to 3 over 2 to the limit 2 to 4. Now it's time to apply the limit, right? So 2 over 5, 4 raised to 5 over 2 minus 4 over 3, 4 raised to 3 over 2. Hope you understand. First, I apply the limit up to the value 4 for u, minus, now I apply the value for 2 for u. So 2 over 5, 2 raised to 5 over 2 minus 4 over 3, u raised to 3 over 2, and u is 2 now. Right. And you can simplify, and that's it. So this is the process of integrating this term. So it's an easy one, but see, as the integration is easier, but there's something you have to do here. Simplification is more, and you are allowed to use a calculator and make use of calculator and find the exact result here. And this was the next problem. Now we move to the next one, next problem. I think the next problem is very important in this category of problems. And see, from my perspective, I think the problem may be there for exam. So either integral 0 to pi by 2, integral 0 to pi over 2, sine x over 1 plus cos squared x times dx, and that's it. So integral 0 to pi over 2 sine x over 1 plus cos squared x times dx. This is a very important problem. And let's try. And we take u equals cos x. You know why? Because the derivative of cos x is negative sine x, and now sine x is there in numerator. That's why. Now we differentiate du over dx equals negative sine x, and we only have sine x here, so there is no negative. We take this negative to left side, so negative du equals sine x times dx. So we got sine x dx. Now we change the limit too. So x equals 0. So x from 0 to pi by 2. So x equals 0, then u equals cos 0, which is 1. And x equals pi over 2, right, the upper limit. Then u will become cos pi over 2, which is 0. So x from 0 to pi by 2 means u from 1 to 0. Let's substitute integral 1 to 0 sin x dx now as negative du over 1 plus cos x is taken as u, so cos x is now u squared. If you take negative out, it's an easy one. Integral 0 to 1 du over 1 plus u squared, and you must know the integral of this term. Negative is tan inverse u, because 1 over 1 plus u squared is the derivative of tan inverse u. So the L must be tan inverse u. So the limit 0 to 1. I keep this negative out, right? It's a constant, as I said, negative 1. Now apply the values, right? Tan inverse of 1 minus tan inverse of 0 equals negative of tan inverse 1 as pi over 4 minus tan inverse 0 as 0 equals negative pi over 4 is the value. And see, it's easy to solve this problem, and this problem is the most important problem in this category. So, right, study this one. Now we move to the next problem. And the next one in this group is integral negative 1 to 1 dx over x squared plus 2x plus 5. We discussed the integration of this term, this function, in integration of some particular function case, right? So this is a particular function where integral negative 1 to 1, we have a direct method to integrate this one. So dx over x plus 1 square plus 5 minus 1. Hope you understand the process. This process is called the process of computing the square. Right? We discussed this one many times. So you get integral negative 1 to 1 dx over x plus 1 all squared plus 4. 5 minus 1 as 4. Integral negative 1 to 1 dx over as x plus 1 all squared plus 2 squared. X plus 1 all squared, 2 squared is like the equation dx over x squared plus a squared. So 1 over 2 tan inverse of x plus 1 over 2 to the limit negative 1 to 1 is the integral equals 1 over 2 b there. And first let's apply this 1. So tan inverse of, when I apply 1 here, was 1 plus 1 over 2 1. When I apply x equals 1 here, 1 plus 1 is 2, 2 over 2 is 1, minus, now I apply negative 1. So when I apply negative 1 here, it become negative 1 plus 1 0. So tan inverse 0 equals half times pi over 4. Tan inverse 1 is pi over 4, and tan inverse 0 is gone, when the value is 0, and pi over 8 is the integral. Right? And this is how you can solve the problem directly. There's no problem when you solve the problem like this. But there is one more technique to solve this one. So hope you understand this one. The other technique, or actually they want you to solve this problem like this, right? So because they think this is a substitution problem. So we do like put u equals x plus 1. It's not necessary. Still, I tell you, this is the real technique. And now differentiate du over dx equals 1 and du equals dx. Right? Now we change the limit. Now if x equals negative 1, x equals negative 1, u equals 0, and x equals 1, and u equals 2. Isn't it? U equals 2. 1 plus 1, 2. Equals, now integral negative 1 to 1 now has become 0 to 2, 0 to 2. Dx and du are the same, du over u squared plus 2 squared. Now is a direct equation, half 1 by a, 1 over a, tan inverse x over a. For x we have u and a is 2. So half tan inverse u over 2 to the limit 0 to 2. Straight we can apply here. I write over there and half be there, and tan inverse, I apply 2 over 2 is 1 minus tan inverse 0 equals half times pi over 4, that's pi over 8, and we get the same value. We get the same result over here. Right? Is that okay? Now, we have 2 more problems, right? But I think we can finish this topic. So before moving to the next problem, I'll tell you something. And see, in integration by parts, and as I say, it's an important thing, because in many problems we have application of integration by parts. So listen, integral e raised to x times f of x plus f dash of x, and the answer is e raised to x times f of x plus c. Means it's a product, and in the product, the first function is e raised to x, and the second function is a sum. The sum of a function and its derivative. So f of x is a function, while f dash of x is derivative of this function. In such cases, there is no need of integration. Instead, you can write it like e raised to x times the function will be the answer. For example, integral e raised to x times sine x plus cos x times dx. Suppose you got such a big product to integrate. So e raised to x is a function, sine x plus cos x is another function, and it's a product. So we have to apply by parts to integrate this one. But we will not apply by parts. This is a short thing, where after e raised to x, we get sum of 2 functions, where the second one is the derivative of the first. See, this is cos x and this is sine x. And cos x is the derivative of sine x. So the answer will be e raised to x sine x plus c. Hope you understand. So keep this thing in mind. Now we solve the problem. The problem is integral 1 to 2, 1 over x minus 1 over twice x squared times e raised to 2x times dx. And this is the problem. So 1 to 2, 1 over x minus 1 over 2x squared times e raised to 2x times dx is the problem. Now, see, when you find such function, you think of this one, e raised to x times like. Now, I do one thing. I substitute u equals 2x. Then du over dx equals 2. And du over 2. I take this 2 to left side because we are only dx here, equals dx. Now, I change the limit to. I'll change the limit. If x equals 1, u will become 2 times 1 is 2. And x equals 2. Then u equals 2 times 2 is 4. Now from this one, I find the value of x2 where x equals u over 2. So u equals twice x and x equals u over 2. Now let's make the substitution. So integral 1 to 2 has become 2 to 4. So this is 2 to 4 and 1 over x, what's x? U over 2. I change the limit, I change the variable 2. So every x will become u over 2 minus 1 over 2 times. If x is u over 2, what's x squared? U squared over 4. Hope you understand. So u is x is u over 2, so x squared is u squared over 4 times e raised to 2x is taken as u, so e raised to u times what's dx is du over 2. So instead of this dx, we can write du over 2. Now let's make some simplification. And integral 2 to 4, 2 over u. I use the reciprocal to multiply. To divide, we have to use the reciprocal and multiply. Minus 1 over cancel as 2 times. So I write this 2 over u squared times e raised to u times du over 2. And integral 2 to 4, 2 taken out. 2 is common in both the terms. So 1 over u minus 1 over u squared times e raised to 2 times du over 2. And this 2 and this 2 can be cancelled. Now, in a 2 to 4, I plan to write this term first. So e raised to u. I write it first. What's the problem? There's nothing. So e raised to u times 1 over u minus 1 over u squared times du. When you reach here, you must understand 1 over negative 1 over u squared is the derivative of 1 over u. So, all right, here, d by dx of 1 by x equals negative 1 over x squared. That's it. So, after e raised to u, we got a function plus its derivative. So the answer is e raised to u over u to the limit 2 to 4. Now apply the limit, so you get e raised to 4 over 4, both minus e squared over 2, right? And so you can take e squared over 2 out if you want. E squared is common in both the terms, over 2 is common in both the terms, so now e squared over 2 minus 1, right? And this is the value, right? This is how we integrate. And that's it. Right, and let's solve one more problem with this topic is over, and we can see we have solved every problem in this category. And the problem is integral 1 over 3 to 1 is actually it's an objective type problem. Still we try to solve x minus, I think it's x cubed to the power 1 over 3 over x raised to 4 times dx. And to solve this one, before substitute, we make some simplification, we do some simplifications, and we transform the problem. So 1 over 3 times 1, and from these two terms, I take x cubed out. So x cubed times, if I take x cubed out from this term, that'll be 1 over x squared. If you have some doubt, you just multiply So x cubed times 1 over x squared is x, right? And minus 1. And don't forget, all raised to 1 over 3. All over x raised to 4 times dx equals integral 1 over 3 to 1 x cubed, and I separate them, I'll give them power to both the terms. So x cubed raised to 1 over 3 times 1 over x squared minus 1 raised to 1 over 3 x raised to 4 times dx. Now equals integral 1 over 3 to 1, this is x, right? X cubed all raised to 1 over 3 is x times 1 over x squared minus 1 over 3 over x raised to 4 times dx. Cancel, and this is x cubed. Now we make some substitution. I'll put u equals 1 over x squared. I take this as 1 over x squared minus 1. So the whole term is taken as u. U equals 1 over x squared minus 1. And see, to make you comfortable, while you differentiate, I write as x raised to negative 2 minus 1. Am I right? So 1 over x squared is x raised to negative 2. Now du over dx equals x raised to negative 2 times x raised to negative 2 minus 1. That's differentiation. So d by dx of x raised to n equal n times x raised to n minus 1. n times x raised to n minus 1. Negative 1 is a constant, its derivative is gone. Now, negative 2 over x cubed. I think so. This is negative 3 by x cubed. Now, we have by x cubed here. So, I take this negative to left side. Negative du over 2 equals dx by x cubed. Hope you understand. Negative taken to left side and dx taken right side and 2 taken to left side. So let's substitute. Equals. Now if you want, you can change the limit too. And if you change the limit, right, I'll write over here x equals 1 over 3, then u equals I'll become, alright, 1 over 1 by 9 minus 1 equals 8, I think, right? And x is approaching 1, so x equals 1, then u equals 0. So integral 8 to 0, am I right? It will become 8 to 0. 1 over x squared minus 1 is now u, and u raised to 1 over 3 times dx over x cubed. dx over x cubed is now negative du over 2. And we take negative half out, and let's integrate u raised to 1 over 3 plus 1 over 1 over 3 plus 1 to the limit 8 to 0. And negative 1 over 2 be there. U raised to 4 over 3, over 4 over 3 and 8 to 0. And you know, there is no need of applying 0 here, just apply 8. Hope you understand. And that's all. And we have finished. We have solved every problem in that category, and that's it. Right? And study well.